Hi everyone, in today's lesson we're going to talk about data that is skewed. Data that is skewed means it just has a long tail on one side. So if you look at this picture here, here's the tail on this side, here's the tail on this side. This middle one is a normal distribution where there is no tail. In a normal distribution, the normal curve represents a perfectly symmetrical distribution. It's centered, it's perfectly symmetrical around the mean, median, and the mode. Now if we talk about data that is skewed to the left or negatively skewed, the tail is going to the left. If we talk about data that is skewed to the right, the tail is moving to the right in a positive direction. So let's analyze these three things. Okay, the first one. Here, data that is negatively skewed. Here are the frequency up here on the y-axis, and on the x-axis, starting at 0, so if I put 0 here, it would be 0, 1, 2, and so on and so on. So the mean would actually be the smallest, then the median, then the mode. So that's what we're going to put in here, that the mean is the smallest, so it's less than the median, which is less than the mode. Now if you look at example number 2, in a normal distribution curve, the mean, the median, the mode, they all represent the same line, so they're going to go down to the same data value, so they're all equal. So the mean is equal to the median, which is equal to the mode. Now the last part is data that is skewed to the right, or positively skewed. So look, the mode would be the smallest now, then the median, and then the mean. Remember, it starts at 0 and it goes 1, 2, 3, 4, and so on, or whatever the scale is. So the mode would come first, which would be the smallest, then the median, and then the mean. So we have mode is smaller than the median, which is smaller than the mean. Okay, now sometimes I can give you data represented in different ways. I can give you these examples here where I have a histogram or I have a dot plot, all of which you learned in 8th grade. We're going to talk about how to make them, but can you tell how this data is skewed? I know the way that I showed you before was just this curve up here, but can we relate that to these 6 examples here? And we absolutely can. So if we just put little dots on top of each of these histograms and connect them, we have data that has a tail, see down here, that is being skewed to the right. So skewed right. Now let's do an example of a dot plot. So if you connect all the dots, and we're going to go up like this, data is skewed to the left. It's going down this way. That's where the tail is. So skewed left. Okay, why don't you take a minute and see if you can figure out these last 4 examples here, and then hit resume when you're done. Okay, here are your answers. Okay, so we have skewed left, we have exactly normal, skewed right. I said this one's neither, but it looks approximately normal. It's centered around the mean, but see how these two aren't even on this side, and then these two aren't even on this side, but in this normal curve, these two are exactly the same height, these two are exactly the same height. So this looks exactly symmetrical, so I'm going to say this one is neither. Okay, let's move on to the next page and actually create some of these things. Okay, in example number 2, we have a table that gives us the heights of a random sample, underlined sample, of 14 college basketball players. So these are their heights. So let's take a minute, put this in the calculator the way that we did yesterday in class, and find these values for me, and then hit resume when you've finished. Round all values to the nearest hundredth. Okay, here are your answers. These were a few things you needed to look out for. Standard deviation, you needed to use SX because it talked about a sample. Variance is standard deviation squared, and interquartile range is Q3 minus Q1. Okay, so let's see if we can answer these 2 questions. Determine how many players fall within 1 standard deviation of the mean. Well, what is the mean? So the mean, let's write X bar. The mean is approximately 70. Now let's go 1 standard deviation above. So let's add 1. 1 standard deviation, though, is 1.73. So we're going to add 1.73 as 1 standard deviation, and we will get approximately 71.73. And now we're going to subtract 1 standard deviation, so subtract 1.73. So take 70 and subtract 1.73, and you should get 68.27. So if we want to find out how many players fall within 1 standard deviation of the mean, we have to account for 1 full standard deviation above and 1 full standard deviation below. And 1 full standard deviation is 1.73. So we're looking for values between these two endpoints. So if we look here, is 70 in between 68.2 and 71.7? The answer is yes, so this one's good. Is this value here of 69 in between those values? Yes. How about 72? No, 72 is out here, right? If it goes 68, 69, 70, 71, 72 is out here. It's not in between these two values. How about 70? 70 is. How about 68? Well, the cutoff is 68.2, so 68 would actually be out here, so no. 71, yes, because it's 71.73. 70 works. 69 works. 71 works. 70. 67. Where does 67 fall? 67 is down here somewhere, so no. 69, yes. It would be in the middle. 71, yes. And 73. No, 73 would be out here. So how many of these players fall within here and here? So let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer to part B is 10. Now it says what percent of this data falls within 1 standard deviation of the mean? A percent is a part over a whole times 100. So the part that we have is 10. 10 of these players were within 1 standard deviation of the mean. So 10 out of a total of how many players? Well, there were 14. So 10 out of 14 times 100. So if you want to put that into the calculator, put in 10 over 14 first, and then times it by 100. And you should get, let's round this to the nearest hundredth as well, approximately 71.43%. So approximately 71% of the data falls within 1 standard deviation of the mean. Okay, let's refresh our memory about how to sketch a dot plot. So a dot plot, you're going to need to encompass all of these values. So what is the smallest value on here? It looks as though, if I look quickly, it's 67 would be the smallest value, and the highest value would go up to about 673. So we need to include all of those values on this line down here. And it's a small enough range that I could probably count by ones. So we'll start at 67 and put a tick mark. You don't have to start at 0. 68, 69, 70, 71, 72, and 73. Now what we're going to do is we're going to put a dot. I'm going to use, I know it says dot plot, but I'm going to use X's because it's easier for me to draw. So I'm going to put, every time I see a number, I'm going to cross it off and put an X where it belongs. So 70, I'm going to cross off 70, and I'm going to put an X right here. Cross off 69, put an X right there. 72, 70. Alright, you don't have to watch me do this. Pause the video, do the same thing, see if it looks like mine. Okay, here are your answers. Okay, now your dot plot should look something like mine. Now, can we tell whether this, I know this question's not here, but can we tell whether this data is normal or skewed? Well, it looks like your center is your mean, and is your median the same thing? And is your mode the same? Is your mean, your median, and your number that appears the most the same? Yes. And is it perfectly symmetrical? Perfectly symmetrical. These two are the same height, same height, same height. So I would say this is normal data, which is pretty cool. Okay, now let's make a histogram for this information. So the way that you want to set up a histogram is that on the y-axis you always want to put the frequencies. And on the bottom, you're going to put the data values. Okay, so if we want to label the frequency, we first have to see how high these things will repeat. That's what frequency really means. So this will repeat once, 1, 2, 3, 1, 2, 3, 4. So 4 would be the highest. So I think I'm going to go up by threes, put a 1, 2, 3, 4. And for the data values, technically on a histogram, you're starting at 0, but my dot plot, I started at 67, so I'm going to just put a little bit of a break into my graph here on the x-axis. So now this will allow me to put 67 here, 68, 69, 70, 71, 72, and 73. I'm going to try to write these numbers in, but it's difficult to write with this stylus, so bear with me. 71, 70. There we go. Okay, so if you need to pause the video and set up your graph, do so at this time. Okay, so now let's get started. 67 has a frequency of 1, so we're going to put a bar ending at 67 at 1, and then we're going to make another bar for 68, same place because it only has one frequency. 69 has 3 frequencies, so we're going to go up to 3 for this one. Then 70 has 4, so for the next one, we'll go to 4. Then 71 has 3 frequencies. And then 72 and 73 both have 1. And as you can tell, this graph is perfectly normal and perfectly symmetric about the mean. Your mean is 70, and this is a perfect looking normal curve. So in class tomorrow, we're going to talk all about how to graph dot plots, histograms, and how to gather information from list values like we did here. So any questions that you have, please jot them down and ask tomorrow. All right, have a nice night.